So now that we've talked a lot about the concepts of streams, let's take a look at a case study that will hopefully bring it all together. And this case study is my ex45 case study, which is in the ex45 project in my Java 8 folder in my Live Lessons GitHub repository. By the way, if you ever wonder why I name these things something obscure like ex45, it's to make it easy to fit them onto slides, because I can put them there and I don't have some giant name that would run over and make it hard to follow and click on the link. This particular case study searches for words and phrases in the works of Shakespeare. What a concept. And we're going to talk here about the utility classes that use Java streams extensively to implement the classes. And then we're going to talk in the next part of the lesson about how it's used by the driver program that actually does the bulk of the work to look for phrases and words in the works of Shakespeare. So the overall program shows how Java regular expressions, regexes as they're called, can be used in conjunction with Java sequential streams to search the complete works of Shakespeare for certain words and phrases. So the particular word and phrase we're going to look for with regular expressions is the word Lord, which occurs all over the place in Shakespeare, as you might imagine. And it's going to be followed by anything ending with, or not ending with, but including true or false. So you can see here some quotes like, Lord, 'tis very true, or Lord are false, or Lord, 'tis true. There's lots of Lord, 'tis true kinds of things over and over again. That must have been a common phrase to say in Shakespearean times in England. So that's what we're going to do. And of course, it would be trivial to change this to search for other stuff, but that's what I chose to make it very specific. This project is organized into several files and packages, just like all projects are typically. And one is the driver program. That's what actually does the searching for words and phrases in Shakespeare. And then we've got a couple of utility classes, one called BardDataFactory, which reads the works of Shakespeare and turns them into a list of strings. And then the RegexUtils, which has a bunch of methods that handle regular expressions in the way that we're trying to do them here. If you ever wonder why Shakespeare is called the Bard, you can click on this link and it will tell you why. That will not be on the quiz, so don't have to worry about that. And then finally, we have another folder, which is very common in Java programs or Android programs, which is the resources folder that contains the complete works of Shakespeare. And they all occur in one file, and we'll talk about that in a second. So let's talk about the BardDataFactory class first. So it's a utility class. I'll explain what that means in a second. And it uses Java streams in a very clever set of ways to read the contents of a text file, which contains the works of Shakespeare in this case. And it returns the contents as a list of strings. So each string is a separate work of Shakespeare. So Hamlet, Macbeth, Julius Caesar, Romeo and Juliet, and then I glom all the sonnets together into one string. What is a utility class? A utility class in Java is a final class, which means you can't extend it. It only has static methods. It has no non-static state, if it has state at all. Often doesn't have any state. And it has a private constructor, so you can't make an instance of it. And so it's basically just a grouping of methods. In C++, we'd probably call it like a namespace or something where you'd have just a bunch of methods in there, or static methods. The BardDataFactory class reads the works of Shakespeare from a text file, which we call Shakespeare data file, which is a string in the ex45 class. And this is kind of what it looks like. We'll look at this in more detail later. But we say BardDataFactory, get input, which is a static method, so we don't need an instance. Here's the Shakespeare data file name, and we're going to give it a splitter symbol. And this is what's going to be used to split the contents of the file up into the separate works of Shakespeare. And this is just a highly abstracted view of what the file looks like. So it starts out with the sonnets, then we have the @ sign, the tragedy of Hamlet, the tragedy of Hamlet text, @ sign, the tragedy of Julius Caesar, the tragedy of Julius Caesar text, et cetera, et cetera, et cetera. And you'll see how we use regular expressions to split these things up very trivially in a cool way. So let's look and see how this works. So this is the getInput method. And the getInput method returns the input data in a given file as a non-empty list of strings. And it takes the file name and the splitter as parameters. We then call a helper method that comes out of the Java class library called classLoader getSystemResource. That will go into the resource folder, find the file, open the file, and then, or not open the file, it'll find the file and return the file as a URI, which is basically a path name. We then take that path name here, and we are going to read the contents of the file as a giant array of bytes. And there's actually a fairly large amount of bytes in the works of Shakespeare, several megabytes. And so what we end up with here is a string that contains all the bytes in Shakespeare. And then we're going to use a regular expression method called compile. Compile takes the split character, which in this case is the @ sign, turns it into a regular expression, and then it will split this byte array into a stream of strings. So split as stream takes the byte array and splits the byte array into a stream of strings where each string is designated as being delimited by the @ sign, or the split sign, the split character. We then get rid of any empty strings that might be in the stream. There really won't be any here, but we just do this to show how filter could be used. And then the final thing we do is we convert the stream of non-empty strings into a list of non-empty strings, and we return that as the result of get input. So pretty cool, very useful, very interesting way to convert a file into something that's more structured, in this case, based on splitting with regular expressions. The RegexUtils class provides helper methods for handling Java regular expressions. And we'll see that there are a couple of methods here. One's called makeRegex, and we'll look at this in more detail. It's super cool. And it converts a list of strings that contain queries into a single regular expression string. And this single string that's returned matches any string that contains any of the queries that were in the original list as whole words, irrespective of whether they're uppercased or lowercased. And this uses the Java Stream API to perform this work. And the way it gets used is you might have a set of words to match, like cat, dog, mouse, and socks. And then we're going to create a regular expression string from the words to match. And this is what it would look like. I won't spend a lot of time explaining this to you other than to say, the way to read this is, in a case-ignoring way, look for any character that is then followed by the whole word cat, or dog, or mouse, or socks, followed by any character. That's the regular expression. Now, you might ask, how the heck do I know that that's a regular expression, or what does it mean? What is the way you learn that these days? You cut and paste it into ChatGPT, and you say, ChatGPT, what the heck is that? And it will tell you. Really cool. I happen to work with regular expressions a lot, so I vaguely know what this means. But if I didn't know, it would be trivial to find out. In the bad old days, you had a really long road to hoe to figure out what a regular expression meant. Nowadays, put it in the ChatGPT, boom, you get the results. Get first line is also cool. It's going to read the first line of a given input string, which in our case is the title of the work of Shakespeare, but we make this more general. And this uses Java's pattern and matcher classes along with the Stream API. So the way this works is you give it a work of Shakespeare, like Hamlet, and you say get first line, and it'll return the tragedy of Hamlet, Prince of Denmark, because that is indeed the first line. So let's have some fun, and let's go take a look now at how this is actually implemented. So here we are in my ex45 project in IntelliJ, and let's go take a look at RegexUtils. We already looked at the BardDataFactory before, and there's nothing new there. But let's go ahead and take a look at the regular expression utils. You can see that it's a final class, which means we can't subclass. It's got a private constructor, and it's only got static methods and no data fields at all. So here's makeRegex. Remember, makeRegex takes a list of string queries and then converts them into a regular expression in this somewhat obscure form. And here's how we do it. We say, hey, queries list, turn yourself into a stream, please. We now have a stream of strings. We then say, apply the map intermediate operation and pass it the method reference for the quote method of pattern. What quote does is quote takes each of the strings and it puts special characters at the beginning and end of each string in the list of strings. In fact, it puts \Q and \E to indicate to the regular expression engine, treat this as a word that has no special characters with any special meaning in the regular expression world whatsoever. Treat it as literally those characters. Because otherwise, if you had fancy special characters, it would confuse the regular expression matcher. So we now end up with a stream of the queries that are encoded with \q and \e for each one. And then we use the collect method, and this is super cool. We use the collect method with the joining collector, and we say, put the vertical bar, the OR operator, between each of these queries. In other words, we're doing this, right? We're sticking the vertical bar between each of these things. And then put this as the prefix to what you're about to return. And that basically says, do everything in ignoring case, and handle anything followed by \b, open paren, which says match the whole word, and we're going to give a list of words that any of which could match. That's a prefix, and then we put the suffix here, which is the close paren \b dot star. And that says, and anything else is also fine to have on the line as well. So this is going to return, that collect method is going to return everything in the form that we showed up here. I think that is like just the super coolest and most useful thing. And if you ever try to look at this written in some other way, you'll marvel at how concise and elegant this is by using the streams operators. Let's go take a look at getFirstLine. This returns the first line of the string, which is the title in this case. And this uses a technique that you need to be familiar with for programming assignment 2. So first thing we do is we're going to make a stream containing one element. So we use stream of. It's going to make one of something. What is it going to make one of? It's going to say pattern compile, and this basically says match across lines. Question mark M inside of parens, believe it or not, means match across lines. It's the .all operator. Go figure. And we say match across lines starting from the beginning of the line to the end of the line. So it creates a regular expression that matches only the first line of multi-line input. And we take that compiled regular expression and we associate it with the input string that was passed as a parameter. And now we've got ourselves basically a matcher. So we have one matcher. And why are we doing this? Because we want to be able to use the cool streams methods. We want to be able to say, now that I've got a matcher that's connected to the input string, please check to see if there's a match. And we do that by calling matcher : find with filter. So if there is a match, in other words, if there's a line that matches the first line, which it most likely will because we gave it that input, then that's going to convert it into the appropriate, it'll keep the matcher basically. And then we're going to go ahead and say, tell the matcher to find the particular string that we cared about. And we do that by using matcher group, which is another method that returns the thing that matched. So now we should have the first line. And now we've got to get this back into something we can return. And to do that, we use find first, because there's only one of them. But find first is the way you get the first thing. And find first returns an optional. And the reason it returns an optional is because it might have been there were no matches. So we can't just always return something. So it returns an optional, which is an object in Java that either has something in it or not. And if there's something in it, when we call or else, it'll return the thing that was in it. If it was empty for some odd reason, it'll just return a null string. So that's the format you'll need to use throughout your assignment number 2 to convert things like URIs or your URLs into stuff that you can then filter and map and then get the results from. Not everything needs to work that way, but some of them do. OK, so that's basically a walkthrough of the methods that we have for the utility classes.